All right, this is part 2 of the notes. Sorry, they're going a little bit long. I just have a little bit more to say. This is 5.3, compare linear functions. We have just identified that the least x-intercept is the j of x. So the next thing that we need to talk about is which functions have the same end behavior when graphed. So you're going to want to look at the graph in order to be able to identify the end behavior. In order to determine the end behavior, you're going to focus on the right tail. So let's talk about that for a minute. The right side of the graph, this is the left side, this is the right side. Here is the the right tail on both graphs. So if it has a right tail that's pointing up, then it's approaching infinity. Like it just keeps going up forever and ever and ever. If the end behavior is pointing down to the negative region down here, then it's approaching negative infinity. And that means it's just going to go down forever and ever in the negative direction. And how you write that is like a weird sideways 8, like that. So then that one was going down. This one's going up, so it's approaching infinity. All right, so let's take a look at our end behaviors. If I look at function f, the rightmost arrow, it's weird to say it like that, that would be this one down here. That one is pointing down. So on our table here, I'm going to say down, which approaches negative infinity. If I look at the next one is g of x, is what I meant to say. G of x is my orange one right here. The arrow that's furthest to the right is this one up here, and that one is going up, and that's approaching positive infinity. Looking at h of x, the rightmost arrow, that one's this one up here, because down here and then up here. So this one's up here, and that's pointing up, and so that's approaching positive infinity. And then the last one is j of x, and j of x down here, up here. So this one is the rightmost. It's pointing up, so it's approaching positive infinity. Now, which graphs have the same behavior? The same ones is going in behavior is going up. So that would be these three right here. So the answer to that would have been g of x, h of x, and j of x. That concludes our lesson for today. Just a few reminders down here at the bottom of your page. The x-intercept of a function is the point where the graph crosses the x-axis, and it can be found at whatever the x value is, and then 0 for the y. And then the opposite is true for the y-intercept. The y-intercept of a function is the point at which the graph crosses the y-axis, and it can be found at the point 0, y. That's why we discussed at the very beginning that it's whenever x is 0, whatever that y value is the y-intercept, just like here. That's a visual representation for you. All right, I hope you guys have a great day. Enjoy your lesson for today, and I'll see y'all tomorrow.